Okay, we'll start our lecture by solving some exercise example from Unit 3. The topic is linear code. Let me share the screen. This will be lecture 20 for Unit. Okay, it's mentioned there. This will be lecture 20 for Unit 3. It will be extra lecture. So I'll write example from here. Find the generator matrix G dash in standard form. Till example writing, you can write mark your attendance. Find generator matrix G dash in standard form. Standard form, you know what do you mean by standard form? Identity matrix and some X matrix. An identity matrix will have order k if dimension of that linear code is k. Find the generator matrix G dash in standard form for a binary code, means field is F2 for a binary linear code. For a binary linear code C dash, and C is given you. This C dash is equivalent to binary linear code C, binary linear code C with the given parity check matrix. Now here parity check matrix are given with given parity check matrix. With given parity check matrix H. So two parity check matrices are given. So first H is 1 1 0 0 0. It's a length of 5. 0 1 1. कोणी क्लिअर केलं काय लिहिलेलं? Okay. Double 1 triple 0. Next 0 1 1 0 1, and the third row is double. This is first example, and for the same second example. It is of length 7. So 0 1 0 triple 1 0. Next 1 1 1 1 triple 0. Next is 0 1 1 0 1 0 1. Now the question काय ते समजून घ्यायचं. We need to find generator matrix G dash in standard form. आता आपल्याला C या कोडचा parity check matrix दिलेला आहे. Parity check पण स्टँडर्ड फॉर्म मध्ये नाहीये. तर C या कोडचा parity check matrix दिलेला आहे, तर तुम्हाला C चा जनरेटर मॅट्रिक्स काढावा लागेल. C चा जनरेटर मॅट्रिक्स काढल्यानंतर त्या जनरेटर मॅट्रिक्स वरून स्टँडर्ड फॉर्म ऑब्टेन करावा लागेल, जो काय असेल C डॅशचा जनरेटर मॅट्रिक्स असेल. आणि C आणि C डॅश हे काय असतील, इक्विव्हॅलंट असेल. तर गिव्हन C and C dash will be the equivalent. So we'll solve this first. You can make this into standard form. Is it when you get standard form, if your matrix is in reduced row echelon form, Can anyone tell me the given H is in reduced row echelon form? आता इथं आपल्याला आपण काय करतो, जी जर स्टँडर्ड फॉर्म मध्ये असेल IK x, तर आपण H काय करतो, मायनस एक्स ट्रान्सपोज IK असेल इथं. तर आपल्याला H ला या पॅटर्न मध्ये लिहायचंय. H ला या पॅटर्न मध्ये दिलं की आपण G असं लिहू शकतो. म्हणजे H डॅश फाइंड करायचा. आता H डॅश ला इक्विव्हॅलेंट असलं, समजा H डॅश हा पॅरिटी चेक मॅट्रिक्स फॉर C म्हणजे काय, this H is parity check matrix for C means what? It is generator matrix for C perf. Okay, so this is generator matrix for C perf. So C perf is also linear code. C perf is also linear code. For C perf is dimension is 2. You can easily check because sorry, C perf dimension is 3. Then for C dimension has to be 2. You can check it as 2 plus 3 gives 5. So C perf is also linear code. C perf हा linear code आहे ज्याचा जनरेटर मॅट्रिक्स H आहे, तो स्टँडर्ड फॉर्म मध्ये नाहीये. So we can convert into standard form, but before that, to convert into standard form, your generator matrix must be in the form row reduced echelon form. So your first step here is obtain the row reduced echelon form of this matrix H. In the first step, obtain row reduced echelon form of H, and then try to convert it into standard form. H is generator matrix for C perf, means it is parity check matrix for C. So this is the first leading one. Below that you have already given 0. The next leading one should be this, but below and above has to be 0. So make this 0 here by doing the operations. What operations you are doing on the first row? First row plus second row, that operation gives 0. So 1 0 0 0 1 0. Next 0 plus 1, 0 plus 0, 0 plus 1, and it is 1 0 1. And last, okay, here it is 1. Now who is the next leading one? This is the first leading one. Second leading one, the leading one should be the below of that row, and that row the first non-zero entry. So this is the leading one, which is in standard form. I mentioned the column numbers 1 2 3 4 5. This is also generator matrix for C perf, means parity check matrix for C, which is not in standard form, but we can rearrange it. We can rearrange the columns to obtain the standard form of this. So what we do, which is generator matrix of binary linear code C perf, that is parity check matrix for linear code C, binary linear code C. Generator matrix for C perf means it is parity check matrix for C, not in which is not in standard form, which is not in standard form. So obtain H into standard form. How one can arrange this? How one can arrange it? But by doing permutation or rearranging the columns, permutation of the columns, rearrangement of the columns, as सांगा फर्स्ट कॉलम कोणता घ्यायला पाहिजे मी? फर्स्ट कॉलम पहिलाच असेल, दुसरा असेल, तिसरा मात्र तिसरा राहणार आणि तिसऱ्या ऐवजी चौथा येईल, आणि मग राहिलेले इन्क्रीजिंग ऑर्डर मध्ये लिहून टाकायचे. 1 2 4 5 हे परम्युटेशन तुम्हाला अप्लाय करावं लागेल या ठिकाणी. म्हणजे या प्रकारचं रिअरेंजमेंट करावं लागेल. अशा प्रकारचं रिअरेंजमेंट केल्यानंतर पण ऍक्च्युली आपला फॉर्म कसा असतो, याचा फॉर्म आपल्याला कसा लिहायचा असतो ते डोक्यात घ्या. हे बरोबर लिहिलं पाहावं लागेल. व्हॉट इज द फॉर्म ऍक्च्युली? Your form is actually minus x transpose I like this. So identity should be the last matrix. So this arrangement is not okay. This is not okay arrangement. So we'll rearrange like this. You must have I3 adds the last 3 columns. So what you written first 3, you should write it as the last 3. So it is 1 2 and next column is 4, 1, 2, 4. And who is remaining? 1, 2, 3, 5 is remaining. So like this, we can permit so that we get the matrix X and identity. So the equivalence matrix, you call it as H dash. So I'll write last 3 columns first. And third column is 1 1 0, 1 1 0, and last column is 1 1 1. So this is of the form Y into I3, which is standard form generator matrix for C perf, or which is standard form parity check means generated for C perf. Parity check for C, standard form parity check for C. So what is the G dash? How G dash can be written? Again, reverse algorithm can be applied. What is the length of this code? Length of this code is 5 minus K, 5 minus 3, and you should write minus Y transpose here. So it is I2 means 1 0 0 1. Now what is minus Y transpose? In binary, minus Y transpose is nothing but Y transpose. So the first column becomes first row, and second column becomes second row. So which is G dash is generator matrix. It's not for C, generator matrix for some code. You can call this name as C. And since the permutation is done, C and C dash are equivalent. Where C and C dash are equivalent. You got all of this? सर्व कळलं तुम्हाला? अनम्यूट करून बोला कोणतरी. दुसरा तुम्हाला सोडवता येईल याप्रमाणे. Second problem, can you solve? Here in the earlier example, generator matrix was given. Although it is parity check matrix, but this is parity check matrix means it should be generator matrix for its perf. Perf means orthogonal complement of that code. You can talk. Unmute करून बोला कोणतरी. सागर. सागर कुठे गेला? अनम्यूट करा. सोमवंशी आहेत का? सोमवंशी?
हो सर आहे.
हा, असं नाही काही?
नाही सर.
हा प्रॉब्लेम सोडू शकता?
हो.
सॉल्व करा बरं सगळेजण. This is parity check matrix for C, means generator matrix for C perf. And number of columns you can mention here: 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 columns were given. हेच दिलं होतं मी तिथे वरती, का वेगळा दिलाय? ओके, हाच दिलाय, पण जरा काहीतरी लिहिण्यात गडबड झाली. 0 1 0 1 1 0. ओके, हा मॅट्रिक्स लिहायचा तिथे. मी दुसराच लिहिलाय वरच्या एक्झाम्पल मध्ये. 0 1 0 1 1 0 1 1. हा चौथा डबल झाला पहा. चौथा समजू नका इथे. दिस फोर्थ इज रिपीटेड 1. त्यानंतर 1 1 0 1 0 1 1 0 0 0 0 1. ओके, हे नंबरिंग परत करावं लागेल. 1 2 3 4 5 6 7. ओके, लेंथ इज 7. पुन्हा स्टेप्स त्या फॉलो करा. याचा you find its row reduced echelon form in the first step. We can exchange these two rows here easily to become one here. Exchange these two rows. So what we get? 1 1 1 1 0 0 0. First row is exchanged with second row. 0 1 0 1 1 1 0. And the last row as it is 0 1 1 0 1 0 1. You should mention the operation while writing in your notebook. I'm not mentioning the operations. I just did the exchange. Oh, what next operation should I do? Now this is first reading one. Huh? This is first reading one. Now its dimension is 3. So you must have I3 obtained from this because parity check means all the rows are generated per C perp. So this is the leading one. Make at this place 0, at this place 0 by adding second row to first row and third row. So by adding to second row to first and third row, we will get like this. So we have done calculations like this. The 0 there is no change by adding 0. Here it is 1. So 1 plus 1 here you will become 0. It is 1, 0. So here it is 1, 0, 1 plus 1 becomes 0. Here it is 1, 1, 1. And here 0 is there, so no change. Okay. So this is the first leading one, this is second leading one, and you have to make this as third leading one by doing the operations. So what operations? Add the third row with the first row. Adding third row with the first row, you get like this. Adding third row with the first row. Okay, this 1 plus 1 becomes 0, 0, 1. Next, last element is 0, so 0 added everywhere. Last element is 0, so 0 is added everywhere. So it becomes 0, 1, 1, 1, 0, 1. 1 is added to first row. Okay, like this you get. First, second, third. This is equivalent matrix. 4, 5, 6, 7. This is parity check matrix, which is not in standard form. But we can rearrange its columns to get standard form. So last 3 columns should be 1, 2, 3. So I3 you should get. So this last 3 columns should be 1, 2, 3. And the remaining writing increasing order 4, 5, 6, 7. So like this arrangement you have to do. That will be your H dash, and H dash will be the equivalent, H dash will be the parity check matrix, which is equivalent to code C. So I'm writing H equal to. Now this is H dash. It's not H dash. This is not H. I'm writing H equal to. The fourth column is 0, 1, 0. Fifth column is 1, 0, 0. Sixth column is 0, 1, 1. Seventh column is 1, 0, 1. And write I3 as it is. So this is parity check matrix, which is standard form parity check matrix for the code C dash. And C and C dash will be the equivalent. So by applying the algorithm to find generator matrix, what is G? Now you should write in I3. Now this has a form. It has a form Y into I3. G must have form I suffix, the length is 7. 7 minus 3 minus Y transpose. In the binary, minus means plus, no problem. So you have to just write transpose. But while other field, you be careful with this. So you get identity matrix of order 4 here. So this is I4, and each row you write it as column 0, 1, 0. The first column of H dash is 0, 1, 0. So it is 0, 1, 0. Second, it is 1, 0, 0. 1, 0, 0. Third, it is 0, 0. Third, okay. Third, it is 0, 1, 1. Third column 0, 1, 1. It's not third. I am saying that this is this first, second, third. Here fourth means seventh. It is 1, 0, 1. And minus 1 means plus 1, minus 0 means 0 in the binary. 101. This is G dash actually. So G dash is standard form generator matrix for the code C dash, and C dash is equivalent to C, because we are just doing the permutation of the columns. Rearrangement you have done. You didn't multiply to any fixed position. Huh? Do you find any difficulty in this example? या एक्झाम्पल मध्ये काय अडचण आहे का? व्हिडिओ चालू करा. स्टार्ट युअर व्हिडिओज. स्टार्ट युअर व्हिडिओज. लिंबाळकर शुभम, एनी डिफिकल्टी? एनी डिफिकल्टी? नो. ओके. तर तुम्ही 4 जणच लेक्चर पाहतात, बाकीचे स्टार्ट व्हिडिओ चालू करा म्हणलं तरी चालू करत नाहीत. असं त्याचा अर्थ आहे. एक व्हिडिओ बंद करू शकता तुम्ही. Construct binary code C of length 6 as follows. Construct binary code C. Construct binary code of length 6. साहेब अनम्यूट करा. Of length 6 as follows. For every x1, x2, x3, this will be compulsory from f to 3. Construct 6-bit word x1, x2, x3, x4, x5, x6. This is from C. C has length 6. F3 मध्ये आपल्याला 3 वर्ड दिले, त्यावरून ते कन्स्ट्रक्ट करायचे पुढे. Where x4 can be written as the sum of first 3. x5 is written as x1 plus x3, and x6 is written as x2 plus x3. First, show that C is linear code. अगोदर तो linear code दाखवा. First, show that C is linear code. If possible, you can find its dimension and length. Length you can see clearly. Find dimension and length of C. If possible, you can find distance of it. You know the results. Third, if you find generator matrix and parity check matrix, then you can find distance. Find generator matrix and parity check matrix. Find generator matrix and parity check matrix for the linear code C. And hence, hence you find distance of it also. Find distance of C also. Means you are finding all the parameters of C. So what was given to you that how C is constructed? Before that, x1, x2, x3. These are all the words from f to 3. And all there are 8 words. Out of 8 words, which satisfy the given conditions that C you need to find. So what C have written? C is of length 6. x1, x2, x3, x4, x5, x6, in which all are binary. The condition here is that your x4 should be the sum of these two. x5 is sum of first and last, and x6 is x2 plus x3. And this is obviously linear code. Linear code means you need to show that it is subspace of this. You need to show that subspace of this. You need to find size of C. Once you find dimension, you can easily say what is size of C. So how one can find this? How one can show this? So I write in matrix form. One can write in column form also this as the x. This x means I called it as x. The x such that what is the condition on this x? So you write all the equations. What are the equations from the first equations? It is x1 plus x2 plus x3 minus x4 means it is plus x4 equal to 0. Next homogeneous equation, x1 plus x3 minus x5 equal to 0. And the last homogeneous equation, x2 plus x3 minus can be written as plus x6 equal to 0. So it is solution space, it is null space actually, and it's a subspace obviously, it is a subspace, but that you need to verify. You need to verify it. So you are writing all those x such that now write this matrix form. What is the matrix form for the first equation? Matrix form for the first equation, x1, x2, x3, x4, x5, x6 are 0. Second equation, x1, x2 is 0, x3 is 1, x4 is 0, x5 is 1, and last x6 is 0. And the last equation, x2 is 1, x3 is 1, x6 is 1. And you are writing this x, x4, x5, x6. This is 0. So it's a null space of matrix A. Solving this means it is null space of matrix A, which is obviously subspace of this. So C equal to x in F26 such that Ax equal to 0, where A you should write from above. Write this A from above. So C is null space of A, which is a subspace of F26. Null space upon subspace दाखवू शकतो. Null space, row space, column space, all are the subspace. Or you can easily show that if x1, x2 satisfies, you can easily show here also that. If you want to verify, it is suppose x1 and x2 belongs to C and alpha belongs to F2. For the binary, alpha is your 0 or 1. So what is x1 plus x2? A into x1 plus x2 kail. Ax1 plus ax2. X1 in C means ax1 is 0. X2 is in C means ax2 is 0, so it is 0. So addition is closed. In this way, x1 plus x2 belongs to C. And similarly, for binary, you need to check only this condition. No need to take this alpha. If alpha is 0, then it is okay. And if alpha is non-zero, then it is 1. So you have checked already. For binary, you need to check these conditions. So in this way, C is linear code. What is the length of it? Now from that A matrix, you need to find generator matrix. Your C is obtained from this matrix. The matrix A, you should write once again. What was matrix A? It is 1, 1, 1, 1, 0, 0. Its length 6. Second row is 1, 0, 1, 0, 1, 0. And the third row is x1's coefficient is 0, x2 coefficient is 1, x3 is 0, and x6 is 1. So from this, you should obtain generator matrix. You should find dimension from this. Just obtain the row reduced echelon form of this matrix. At this step, obtain row reduced echelon form RREF of A. And this can be done easily. You write the operations what you are performing. So to obtain row reduced echelon form, you need to apply only row elementary operations. So this is 1. and we can make 0 here by adding to second row. So the equivalent matrix I will write here, the first row as it is, 1 plus 1, third row there is no change. Okay, Kali Vaishnavi, unmute करून बोला तुम्ही.
सर इथे कॉलम 4, 5, 6 आयडेंटिटी मॅट्रिक्स आहे ना.
4, 5,
6 कॉलम.
पण आपल्याला हा ठीक आहे, तसं आपल्याला पण आपण कॉलम ऑपरेशन करत नाही ना रोड रिसिक्लम फॉर्म मध्ये. रिअरेंजमेंट आपण इक्विव्हॅलेंट मॅट्रिक्स इक्विव्हॅलेंट कोड आपण करत नाही ते. We are not doing equivalent code here. We should have standard form like this. What is standard form for G? I3X in this case. So हा I3 म्हणू नका याला. आपल्याला रँक याची 3 दिसते. पण इथं कॉलम एलिमेंट कारण हे कोएफिशिएंट ऑफ x1, x4, x5, x is coefficient. We find the coefficients. As per the equivalence is concerned, at that time we will think. We are not finding the equivalent code. We are doing for C. MCQ साठी तुम्ही याचा विचार करून त्याचा डिस्टन्स वगैरे काढू शकता. त्याचा अडचण नाही. पण या प्रॉब्लेम तसं करता येणार नाही. आपल्याला सुरुवातीलाच I3 आणावं लागेल. फक्त C साठी करायचं असेल तर C डॅश साठी म्हणजे इक्विव्हॅलेंट साठी केलेलं चालतं. आलं लक्षात? Got it?
हो सर.
Okay. Good करा. So 1 plus 1, 0 plus 1, 1 plus 1, 0 plus 1, 1 plus 0, 0 plus 0. This is the second leading one. Now I will perform operations here only. While writing, you write separately. Yeah? What operations I need to perform here? In the first row, you are doing operations making 0 here. Huh? So this the middle element is added to above element. There is no change. So this 1 plus 1 gives 0. 1 plus 0 is 1. This 1 plus 0, 1 plus 0. And because of this 0, it will be as it is. So this is okay. Now this will be your third leading one, and you have to add to first row. So here no change. You are doing operations to make 0 here. So here you get 1 plus 0, 1 plus 1. Here it is 1. And okay. Finally, you got the matrix, required matrix. I will rewrite it. Due to time, I am doing fastly. These operations you can perform easily. Since you are not finding the equivalency, you are finding for the same code. So don't permutations. You are doing the exchanging of the coefficients. The code will be different. Okay, whatever code you obtain, you get same parameter as of C. As per the parameter concern, you can do that also. Okay, it has standard form I3X. The last question you are solving. This is standard form generator matrix. Why you doing standard form? Because you want to find parity check for this also. That's why. This is the standard. This is generator matrix for given linear code C having dimension 3. Easily you can check. And what is H? H is minus X transpose length minus the K. So minus X transpose as per the binary concern, it is same thing. So I'll write I3 at last. And what is X transpose? My X transpose is this is your X. This is your X. You are writing transpose of it. Means this column 111 becomes as a row. This will be row. And यांचा आपण product केला तर 0 matrix ला H into D transpose. 011. And the last meeting may end in 1 minute. Okay, 101. I will conclude this. 101. It is 101. So this is parity check matrix for C. This was asked. And lastly, parameters were asked. Parameters were asked. This length is 6. Dimension is 3. What is distance? Distance will be decided from this. If distance is D, you must have any D minus 1 column should be linearly independent. You recall that result. Any D minus column should be dependent and D column should be independent. Now here 3 columns are easily you can find these 3 columns are independent. Can any 3 columns are independent here? Can any 3 columns are independent here? That we need to check. Or we can apply MATLAB programming to find the distance of this. You just find this D such that D minus 1 columns are linearly independent and D columns are dependent. Any here you should mention any, and here you must have any one D columns which are dependent. Here independent and independent. Then distance is D. So for this parity check matrix, you can perform this. Now by looking at this I3, obviously the three columns are linearly independent. But can any three are linearly independent? No. Any three are linearly independent आहेत का? नाही आहेत, कारण हा कॉलम पाहिला इथे, दिस कॉलम 1 2 3 सेकंड 4 5 4 5 2 डिपेंडंट आहेत, म्हणजे एनी थ्री लिनियरली इंडिपेंडंट नाही आहेत. मग एनी टू चेक करा, ठीक आहे. आपली मीटिंग एंड होऊ शकते कधी वाटल्यास. डिस्टन्स तुम्ही उद्या काढून या, त्याचं ट्रायल एरर तुम्हाला करावं लागेल. विल सी इन टुमॉरोज क्लास द रिमेनिंग पार्ट.